Hi everyone, how is it going? Are you fine? Welcome to our channel. In the previous video, we talked about the remainder theorem and we solved a couple of examples about the remainder theorem. Today we are going to talk about a new topic which is factor theorem. This is also related to the operations of polynomials we have studied before. In factor theorem, what is a factor first? Do you remember what is a factor? Yeah, a factor is a number which can completely divide the given number. For example, in here, look at here, 12 and 4. 12 has many factors, but 4 is one of the factors of 12. How do we know that 4 is a factor of 12? Yeah, when you divide 12 by 4, the remainder will be 0. 3 times 4 will be 12. 12 minus 12 is 0. So anytime when you divide two numbers and the remainder comes 0, so you know that they are the divisor is the factor of the dividend. So in here we say that let the px be a polynomial. Then the following statements are true. We have two statements here. First statement, if p of x has a factor x minus a, then p of a is equal to 0. What does this mean? This means that whenever we divide a polynomial by x minus a and the remainder comes 0, this is the remainder. We have studied in remainder theorem. To find the remainder, we put just the constant term here and the remainder will be anything. So in here, if x minus a is a factor of px, then the remainder will always come 0. In here, we said that 4 is a factor of 12, so the remainder comes 0. So without these numbers, they are in arithmetic and polynomials. Every time you can check that when the remainder is 0, so x minus a is a factor of p of x. From this statement, we will have p of x is equal to x minus a times q of x plus r, as we said in division, plus r or remainder. So in here, if we substitute a here, it will be a minus a times q of x, and we said that whenever you divide a number to its factor, the remainder comes 0. So in here the remainder is 0. As a result, we will have p of a equal to 0. It means that if x minus a is a factor of p of x, the remainder or p of x comes 0, and here we see. And in the second statement, we have if p of a is 0, then x minus a is a factor of p of x. It is the inverse, or conversely, we said that whenever you divide two numbers or two polynomials and the remainder comes 0, so the divisor is a factor of the dividend, and here the divisor is x minus a. So whenever from the second statement we will have that if p of a is 0, then we will have a result. The result is that p of x is equal to x minus a times q of x. It means that x minus a is a factor of p of x. They are the inverse of each other. If p of x has a factor x minus a, then p of a comes 0, and if p of a is 0, then x minus a is a factor of a. So how do we know that a polynomial is a factor of the other polynomial or not? How do we know? So let us see an example here. Look at this example. Is x minus 1 a factor of p of x, for example 5 x to the power of 2 minus 3x minus 2. And the question is given that x minus a, is it a factor of p of x or not? It means if you divide this by x minus 1, the remainder comes 0 or not. So let us check. To check it, first we must find a. In here you can see that a is 1. X minus 1, x minus a x minus 1, and we have x minus a. So in here you can see that a is equal to what? A is equal to what? A is equal to 1. So if you put 1 in here, p of 1 must be 0. If it is 0, so we get the result that x minus a is a factor of p of x. If it not comes 0, if it doesn't come 0, so you can say that the polynomial is not a factor of x minus 1. Sorry, x minus 1 is not a factor of polynomial p of x. So in here p of 1 is equal to p times 1 squared minus 3 times 1 minus 2. From here you can see that 5 minus 3, it's times minus 2. So in here you can see 5 minus 3 is 2, 2 minus 2 is 0. So in here you have a result that x minus 1 is a factor of p of x. This is the result for the first question. Okay, for the next example we will have same question. For example, x minus 2, is it a factor of p of x equals, for example, x to the power of 3 minus 2x plus 5. Let us see that x minus 2 is a factor of p of x or not. Let's check in here. What is a? X minus 2, x minus a, we said that we must divide by x minus a. So in here you can see that a is what? A is equal to 2. From here, p of 2 is equal to 2 to the power of 3 minus 2 times 3 plus 5. So is it come 0 or not? If it is 0, so it is a factor. If it is not 0, so it will not be a factor of p of x. So 2 to the power of 3 is 8 minus 2, 6 is 2 times 3 is 6 and plus 5. In here you can see 8 minus 6 is 2, 2 plus 5 is 7. So you can see that it is not 0, the remainder is not 0, the remainder is 7. So as a result we can say that x minus 2 is not a factor of p of x. So these were two examples for finding or to investigating that a polynomial is a factor of the another polynomial or not. So for the other example, we will have fx plus 3 is a factor of px. We have a polynomial here like this, and also in here x to the power of 4 minus mx to the x squared plus 4x minus 6. And here it says that fx plus 3 is a factor of p of x. So find, we said before that when a binomial is a factor of p of x, then p of a will be equal to 0. So in here we will check that what is a. X plus 3, we can write it as x minus 3 to find a. So if we write x minus a here, so it will be minus minus, and a in here will be minus 3. A is equal to minus 3 as a result. So p of a must be 0 because this is a factor of px. So in here p of minus 3 must be equal to 0. As a result we will have p of minus 3. Place the value of minus 3 here. Minus 3 to the power of 4 minus m. Minus 3 to the power of 2 plus 4 times minus 3 minus 6, and this must be equal to 0. As a result we will have, minus 3 to the power of 4 will be 81, and minus 3 to the power of 2 is plus 9. In here we have minus, minus plus will be minus 9m, minus 12 minus 6 equals 0. From here we will have 81 minus 12 minus 6. 81 minus 12 is 69, and 69 minus 6 is 63. If we transform minus 9m to the other side, to right side of the equation, it will be plus 9m. Divide both sides by 9. The result will be 7 equals m. So in here, we said that fx plus 3 is a factor of p of x. So for value of m as 7, if we put 7 in here instead of m, so it will be a factor of p of x. Okay guys, that's all for today. In the next topic, we will talk about remainder theorem, and to follow our lessons, to follow 10th grade lessons, please follow our channel. Thank you.